have, that implies then that plus or minus the square root of x squared plus y squared is equal to minus 4y. Square that, we get x squared plus y squared equals 16y squared. And so that gives me 15y squared minus x squared equals to 0. Oh, fine. You know what this is? Let me not do that. More to the point, this gives me 15y squared is equal to x squared, which if I take the square root, I get y is equal to plus or minus 1 over the square root of 15 x. It's a pair of lines. That's a pair of lines. Weird, huh? Sorry, I doubt myself all of a sudden. Which number was this? If you guys would just like to know the answer to a particular problem to check yourself, I can tell you right now. I've got it out. Yeah. Wait a minute. Number what? What did I say?
58.
Oh, 58. Oh, man. Huh. Oh, I made an algebra mistake. There is one that's like this. Number 52, I think, works out like this. Number 52, though. Well, number 52 doesn't look quite the same. There was a mistake. Oh. You see where it is? Look at this. You guys just bought into this, but probably some of you saw it. How about this step to here? Is that legit? No, see, I have to multiply. I had to multiply by r before I did that, right? So this is easier than that. So r squared is equal to minus 4r sine theta. So that tells me that x squared plus y squared is equal to minus 4y. And that gives me x squared plus y squared plus 4y equals to 0. You complete the square, you've got x squared plus y plus 2 quantity squared is equal to 4. It is a circle, radius 2, centered at 0, minus 2. Yes. That's so on this side of things, sometimes multiplication by r, the given equation you have, is helpful, right? All right. Section 10.3 is where it starts to get interesting, I suppose. Again, you're supposed to sketch the polar curve. Probably have time for one of these. Sketch the curve and find points at which they intersect. Well, that's interesting. Let's see, number 39 is r equals sine theta, r equals minus cosine theta. Sketch and find intersection points. Yeah. Let's see here. I think the easiest way to sketch these is to multiply. I mean, this multiply by r, right? You get r squared equals r sine theta for the top one. which is x squared plus y squared equals to y. So you've got x squared plus y minus 1/2 quantity squared equals 1/4. So the sine theta is actually the circle where centered where 0, 1/2. So r equal, I think we plotted this one before. I'm sorry I'm working so small. So there's the sine theta one. How about our cosine theta? We have r squared equals minus r cosine theta, which is x squared plus y squared equals to minus x, which is x squared plus x plus y squared equals to 0, which is x plus 1/2 quantity squared plus y squared equals to 1/4. That's a circle centered at minus 1, 0, minus 1/2, 0. So that circle like centered here. That's this one. So you can see geometrically we're looking for two intersection points, right? But I think probably you can find the intersection points without doing this, right? Like you can find these points of intersection without drawing this picture. It asks us to sketch it, so I did, but how do you solve r equals sine theta and r equals minus cosine theta at the same time? Right, you can put them equal. Now, r equals 0 is a special case, right? If you put 0, r equals 0 works because you can make, I mean, the thing is, at the origin, theta takes on all values. The origin's a kind of degenerate case, so the origin is in here, but it's weird, right? So, but anyway, these do, you can try, if you put 0 in here in these equations, it's clear, right? 1/4 equals 1/4. 1/4 equals 1/4. I mean, the origin is on both of these circles, so it is in the intersection of these curves. It's a little bit hard to convince yourself of that. It's less obvious to convince yourself of that with these equations, right? I totally agree about what you said, Thomas, that we just set sine theta equal to minus cosine theta. And that gives you tangent theta equals to minus 1, which has solution minus pi over 4, I believe. But minus pi over 4 is probably, that's down here, so you have to go back up there. In other words, you're looking for where sine and cosine are equal in the second quadrant, and that's here. It's at pi over 2 plus pi over 4. It's at 3 pi over 4 is the solution. So 3 pi over 4 makes these equal. And that makes r equal to what? R equal to 1 over root 2. Anyway, so tomorrow, I don't really have much on my docket. I should probably show you some more like calculus of paths, just some like elementary examples there. And like I said, I'm going to write you a couple homework problems on that. That'll be due Monday. So that hopefully